All right, 6.2, binomial probability distribution. Binomial probability distribution, a discrete probability distribution that describes probabilities for experiments in which there are two mutually exclusive outcomes. So I'll pause right there, let you guys write that. Binomial. So we're saying that there are two mutually exclusive outcomes. Right? These two outcomes are generally referred to as success and failure. Example of that, success could be considered making the shot. Failure would be considered missing a shot. So in other words, we're talking about basketball, talking about making the shot versus missing a shot. All right, experiments in which only two outcomes are possible are referred to as binomial experiments. They're provided certain criteria are met. We'll talk about that in a second. All right, so criteria for a binomial experiment. An experiment is said to be a binomial experiment if, of course, I'm trying to make sure I don't go up too far. Give people a chance to write. Still on black. All right, well, the first one, the experiment is performed a fixed number of times. Each repetition of the experiment is called a trial. So that's the first criteria. Experiment is performed a fixed number of times. Second, the trials are independent of each other. We talked about independence. I believe it was last class that one trial has nothing to do with the probability of the next trial occurring. For each trial, there are two mutually exclusive outcomes, success or failure. So mutually exclusive, we talked about that as well. That means that neither of the outcomes have anything in common. In other words, you can't miss a shot and make a shot at the same time. You either missed it or you made it. So they are mutually exclusive. Then I believe it's the last one. Yep. The probability of success is the same for each trial of the experiment. All right, now hold on to 3. Okay. So notation used in a binomial probability distribution. So lowercase n is the number of trials of the experiment. P is the probability of success. 1 minus P is the probability of failure. X is the number of successes in n trials. So notice X is going to be in between 0 and n inclusive. Mm-hmm. All right, next exercise, determine which of the following probability experiments qualify as binomial experiments. For those that are binomial experiments, identify the number of trials, probability of success, probability of failure, and possible X values.
Hey, Professor, sorry. Could I get the last one for X equals for that one up there? If you just scroll up so I can see the X.
Yep, not a problem.
Thank you.
Mm-hmm.
I got it. Thank you.
Oh yeah, okay, no problem, no problem. Thank you. All right, give you guys a chance to write that before I scroll up. So once again, we want to determine which of the following probability experiments qualify as binomial experiments. For those that are binomial experiments, identify the number of trials, probability of success, probability of failure, and possible X values. So remember, in order for it to be a binomial experiment, it has to fit those 4 criteria. All right. If I scroll up too high, let me know. Okay. So first example or first experiment they want us to look at says an experiment in which a basketball player who historically makes 80% of his free throws is asked to shoot 3 free throws, and the number of free throws made is recorded. All right, so we have to go through the 4 criteria to see if this is a binomial probability experiment. So the first thing that we ask, or the first criteria that needs to be met, is there a fixed number of trials? The answer is yes. They ask him to shoot the ball 3 times. Next one, are the trials independent of each other? Yes. Making one shot does not have anything to do with making another shot or missing another shot. Making a missing one shot has nothing to do with making a missing the next shot. So they are independent of each other. Are they mutually exclusive? Yes. So it is impossible to make and miss a shot at the same time. You know, they have nothing in common. So you either made the shot or you missed the shot. Then is the probability the same for each shot? Probability of success the same for each shot? The answer is yes. He's historically an 80% free throw shooter, so that's going to be the probability. All right, questions on those before we go to the next part of it? So in the green is our conclusion as far as whether it meets a binomial probability experiment or not. So it is a binomial experiment because it meets all four criteria. All right, so the next part of this problem, it says if it meets the binomial experiment criteria, then we need to, establish number of trials, probability of success, probability of failure, and then number of X. So N is going to be 3. That's the number of trials. We get 3 shots. Probability of success is 80%, so it's 0.8 probability of making a shot. Missing a shot, you would take that 0.8, subtract it from 1, so that'd be 0.2, 20% chance of failure. And then your possibilities of success. It could be 0, you could miss all shots, you can make 1, you can make 2 of them, or you can make all 3 shots. So X would be 0 to 3. Remember, your X is always 0 to N. Whatever your number of trials are, you can't make more than 3 shots if all you're giving is 3 shots, right? So X is always going to be the chance of for how many successes possible within a certain number of trials. All right, any questions with that? Excuse me, excuse me. Next one, probability experiment in which 3 cards are drawn from a deck without replacement and the number of aces is recorded. Key phrase here is without replacement. That means you do not put the card back. Once you pull the card out, you do not put the card back. So we have to ask ourselves those same 4 questions. See if it fits the probability, the binomial experiment criteria. So first one, is it performed a fixed number of times? The answer is yes. It says you get to pick 3 cards out of the deck. So it fits number 1. Then number 2, are the trials independent? Remember, independence means that me performing one trial does not affect the probability of the next trial and what goes on in it. So this is not, or our trials are not independent because it says without replacement. Because once I take a card out and if I don't put it back, now I'm affecting the probability. We go from a 52 card deck to a 51 card deck. And then if I were to get an ace, then that takes away the number of aces that I have, all that type of thing. So if I don't replace the card, then I'm changing the probability. And so my trials are not independent. And that means it is not a binomial experiment because it does not meet the criteria. All right, questions? Any questions? Yeah, got one more down there. Anybody still copying purple? Good. All right. So according to the recent Harris poll, 28% of Americans state that chocolate is their favorite flavor of ice cream. Suppose a simple random sample of size 10 is obtained, and the number of Americans who choose chocolate as their favorite ice cream flavor is recorded. All right, so we had to go through our criteria. Are the experiments performed a fixed number of times? The answer is yes. It says a sample size of 10, so we're choosing 10 people. Are the trials independent? The answer is yes. Choosing one person has nothing to do with you choosing the next person. Well, I guess choosing them and them choosing chocolate has nothing to do with somebody else choosing chocolate. Are the trials mutually exclusive? The answer is yes. Um, you either like chocolate or you don't. And remember, I mean, not like chocolate. Remember, it's about chocolate being their favorite ice cream. So either chocolate is your favorite or it isn't. So, not just about liking chocolate, but chocolate being your favorite or chocolate is not your favorite. And the probability for success is the same for each. Remember, the poll said that 28%, I believe it was 28%. Yep, 28%, normally chooses chocolate. All right, questions on the criteria? Make sure we're good. So this experiment is a binomial probability experiment because it meets each of the criteria. All right. So if it fits the criteria, remember we're supposed to establish, the pieces that come along with it. So the number of trials is 10. Probability of success is 28%. Probability of failure, you minus that 0.28 from 1, that'll be 0.72. And the options for X is 0 through 10. So the chance that you choose 10 people and none of them chose chocolate as the favorite, all the way up to 10 people and all of them chose chocolate as the favorite. So that's what X represents. X represents your possible successes. Choose 10 people and only one person chose chocolate as favorite. Choose 10 people and only 2 out of the 10 chose chocolate as favorite, and so on. All right. Any questions? New questions? Scroll up. Mhm. So we have a formula to be able to calculate the probability of a certain number of successes. So in other words, like when we go back here, the probability, I want to know what's the probability of when I choose 10 people, 2 of them would choose chocolate as their favorite. If I want to know the probability, if I choose 10 people, 9 of them would choose chocolate as their favorite. So that's what we're talking about here. So it's the binomial probability distribution function. So we got NCX. That C is not a variable, it's the combination function. And you got P to the X power times 1 minus P to the N minus N power. N minus X power, excuse me. N minus X power. Where X, N, P represent everything we talked about up to this point. X is the number of successes, N is the number of trials, P is the probability of success. All right. Everybody good before we use the formula? So now I will say this, just like before, if you don't want to do this in the calculator, there are calculators out there. If you Google binomial probability distribution function, then all they would do is ask for key terms, not key terms, key pieces. Like they'll ask for X, N, and P. You plug those in and it will give it to you. If you don't have that, then you have to know how to use your calculator in order to do this. And I'll show you what I mean in a second. So according to CTIA, 41% of all U.S. households are wireless only households. That means no landlines. In a random sample of 20 households, what is the probability that exactly 5 are wireless only? So A is exactly 5 are wireless only. All right. So when we look at the pieces that we need, probability of success P is 41%, so it's 0.41. Probability of failure is 1 minus 0.41, which is 0.59. Number of trials says in a sample of 20, so we talk about 20. And then X in general is from 0 to 20. Remember, X goes from 0 to N. All right. So now if I want to know exactly with the probability of picking out exactly 5 wireless households, remember you're going to choose 20. The setup is if I chose 20 households, what's the probability of getting exactly 5 that are wireless? I will put it in our formula. This is the formula right here. That's following this. So just going back to it. So in this case, X is 5. So it's 20C5, 0.41 raised to the 5th power, 1 minus 0.41, or if you wanted to go ahead and put 0.59 there, you could, raised to the 20 minus 5. All right. So if you have the type of calculator, you can put it in calculator like this. If not, you can simplify it some. Notice we did 1 minus 41 gave us the 0.59. 20 minus 5 gave us the 15 right here. Now there is a combination formula in your calculator if you have a scientific calculator. And so, you know, if you don't know how to use a calculator, you may have to get with me on that, or you can Google or YouTube the type of calculator that you have and it'll show you how to use it. But if not, always feel free to get with me on it. But you will need your calculator to some degree, because even if you do this part by hand, which is your combinations, you don't want to have to raise 0.41 to the 5th power and then 0.59 to the 15th power. Okay. So you do want to be able to use your calculator to some degree. Now, once again, if you were to Google binomial probability distribution function, there are some apps, some websites out there that all they would do is ask you for, your number of successes, probability of success, probability for, they ask you for these things. Then when you type them in, it'll just give you the answer, so that is out there as well. So we talked about this, the type of answer that my math lab may present to you. If it says like in the number or in 100 trials, they ask you something like that. In 100 trials of this study, we surveyed 20 households 100 different times. So that's what it means, 100 trials. You serve 100 households 20 different times. And so in 100 households, we would expect 7 trials to result in 5 households that are wireless only. So where they get a 7 from, that's 100 times the 0.0656. So if they said 1,000, then they probably would have said about 70 trials, because you would take the 1,000, multiply it, or they could have said 66, because the decimal would be right here at the 65.6. So whatever this number is for your number of trials, you take that, multiply it to the number that you got, and that's what should be right here. So just throwing it out there as to the type of answer that my math lab would be giving you as an option. Questions. questions. All right, can I scroll up? You okay? All right, so the next one, probability that fewer than 3 are wireless only. So if you're talking about fewer than 3, that's x is less than 3. So this is 0, 1, or 2. So we find the probability of 0 independently, 1, and then 2. I don't say independently, but individually. And once again, this is if I was putting it in the calculator. Maybe next class I'll show you a website that will let you do it, just by putting in numbers. Today I want to make sure we get through the notes. But if you had to do it by calculator, you will set up each one of these in the formula individually. All right, so I said something in chat. All right. So you said from chat, you talking about 6.1. Are you saying you just want the video, or somebody asked me something in the chat? So you can type back. You can respond back in the chat as well. If you're asking for the video or the notes themselves, because the video I haven't sent out yet. So when you do each one of these individually, you get each one of those, and adding them together, you get 0.0028. And my math lab will let you know how many decimal places to go out. And that will be that. Um, all right. So now the next one, we want to know at least 3 are wireless only. So now, if we hadn't done the previous example, that means we would have to do each one of these individually all the way up to 20. You said at least 3. So you're talking about 3 being the least. Then you go from 3, 4, 5, all the way to 20. That means if you remember what we did last time, we did the probability of 0, probability of 1, and probability of 2, each one of them individually. So we don't want to have to do that if we don't have to. So don't forget your complement rule. Since we know the probability of less than 3, we can subtract that from 1 to find the probability of at least 3. So that's what we did here. Now, if we hadn't done the previous problem in order to get this number right here, then we would have to do one or two things. Do each one of these individually, all the way up to 20, or lean on that, like I said, website or app or some type of calculator in which I wouldn't have to do one of those individually, each one of those individually. All right. Questions? Any questions? I got one more. Are we done with C? All right. The number of households that are wireless only, between 5 and 7 inclusive. So what's the probability that if you were to choose 20 households, probability of getting 5 or 6 or 7 family of households that are wireless only? So we're looking at 5, 6, or 7. Do each one of those individually, and then add them together. 0.3381. All right. Questions? Any questions? All right. Scrolling up. Everybody good? Everybody good? What's this down here? Okay, that was somebody's notes. Some other stuff. Okay, so that's it for 6.2. So remember, we talked about what this next test is going to be on and how we're going to handle it. Next class will be your review, day review option. So feel free to bring those questions next class. Um, if you don't have any questions, I guess you don't necessarily have to come if you don't, have any questions. But that will be your opportunity to ask me whatever you like. Then our test will be next Wednesday. Don't forget, I will offer a review for the test. If what was I gonna say? We'll offer a review for the test. Oh yeah, the highest that you can get on that review, or that I said offer review, offer a redo or makeup. There we go. Losing my words. Offer makeup for the test. So on that makeup, the highest you can get is 85. I will give you once again 2 shots. Anytime I put a test in my math lab, I'll give you 2 opportunities to get the best grade possible. So that means actually you would have had 3 opportunities to get a decent grade on that test. One with me proctoring, and then 2 that you would do on your own. And we will go from there. So questions, concerns, comments, anything, anybody? I mean, it's possible, let's be honest, if you even opt out of not taking it that day, then I guess that would be fine. You just said, hey, I'd just rather take a 0. I mean, some people have done that in the past. That's fine, but the makeup will be provided, but you won't see that until after we actually do the in-class test.
So if we do poorly on the proctored one, we can do the makeup one and get 85 points at most?
Yep. Mm-hmm.
Oh, okay. Thank you.
Yeah, no problem, no problem. So
And
basically, okay, go ahead. Mm-hmm.
how much is if we do the practice? I'm almost done with the practice for 3 and 4, and
Mm-hmm.
it's 25 points as a homework. Is that how much extra credit will be added to the test?
No, it'll be 5 to the test.
Oh,
So yeah, it's not really counted homework. When I go in and I do my final grading, that's when I'll make all the adjustments. Just like you wouldn't even see that 5 points added to your test. Really, I'll just do that when I do my final grading.
okay. All right.
Hmm.
Thank you.
Yep, not a problem. So going back to that question about doing poorly on the proctor test. So if you do poorly, basically, if you score 85 or better, there's no reason for you to retake the test. But if you score less than 85 and you want to, try to up your grade, then you still have 2 more shots on your own to get, bring your grade up as far as the test is concerned. All right. So anybody else before we close? Everybody good? Straight. All right. So you guys have a good one. Be safe. Have a great weekend, and I'll see you on next class.
Thank you.
Thank you. Have a good one.